Okay, you guys, related rates. If you don't do the problems, you guys, this is probably going to be a free response. You don't want to miss 1/6 of the questions. So you need to learn how to do this. We're doing the first one, the one that's up here. It says right here. Now, sand is pouring in. Hey, guys, and I may not get to the second one. Okay, Noah, Maya, it's pouring in at 16 cubic feet per second. So I know that. It's 16 cubic feet per second. Here's what you have to do in the back row, Jack. You have to be able to read. And you need to know what cubic feet is. What's cubic feet? Good. What is that a measure of? Volume. Especially in the back row, because you guys missed yesterday. PT. What do I have? What? I don't have any C kits. Okay, you guys. No, I'm not going to do that. Hurts my voice to talk over you. Just waiting for you guys to be quiet. Usually you're pretty good. But I'm not going to rush through this because it's not going to do any good if you don't get it. It says if the falling sand forms a pile that's a cone, the altitude is always 1/4 the diameter of the base. How fast is the altitude increasing when the pile is 4 feet high? Gave you the formula here. And the only thing we can label on our diagram are things that stay constant in time. Nothing stays constant. You think about it, if sand's pouring, the radius is going to change, isn't it? The diameter is going to change, and the height's going to change, if you've ever seen that happen. But we will label those things that change in time with some letters. Knowing that the volume is that formula, what do you want to call the altitude? H. And I'll call the radius R. You can use whatever letters you want. It's just easier to stay with the accepted letters in my formula. Okay, the altitude, H, is always 1/4 of the diameter. So what's the diameter equal to? It says so right there. 2R. So H is equal to 1/4 of 2R. R over 2. Okay? Stephen, question? Now, how fast is the altitude increasing? Jacob, what am I going to write for that? I know, because you need to pay attention so you get this. This is the altitude. I want to know how fast that's increasing. That's a derivative. That's dH dt. When the pile is 4 feet high, what's the 4 feet? H. And here's the secret to doing related rate problems. If you write this, by the way, you often get the 1 point for saying dV dt equals 16, which is amazing that they give you a point for that, but they do. So even if I don't know how to do the problem, just doing the find, give, and a when will probably earn you a point. Now, we want to relate H and we want to relate V. I've got this formula here, so I have a variable there because R is changing in time. I don't want R. Can I get rid of it? Sure, because I can solve this equation for R. What's R equal to? Now, and as I do in algebra class, they don't want to solve their equations. They want to go right into solving it. They got parentheses, they got 2x and 3x. They go, why don't you simplify everything? So we're going to simplify it. So it's 1/3 pi, then it's r squared times h. But r was 2h. And if you take the derivative now, you must use the product rule. So I don't want to do that. We always simplify. You never put in the constants until after you've taken the derivative. So if I multiply that out, volume equals pi over 3. That's from the first two factors. What's 2h quantity squared? 4h squared, and then I have another h. I can still simplify. That's the same as I do in algebra class. I don't want to try and work with that yet. Because what's 2h times 2h? 2h times 2h. That gives me 4. H times h is h squared. Well, hang on. So it's 4 pi over 3. I'm going to put all my constants together. And what does h squared times h equal? H cubed. Now, doesn't that make sense dimensionally? It better be cubic, right? Okay, so then what do we do? Take the derivative. Okay, so d dt. Now, you guys, we've done this a lot of times. We don't have to take the derivative of the constant. Just pull the operator right through there. Because the derivative of the constant is 0, and I'd have to use the product rule, and I don't want to do that. I'm lazy. Whoops. And the bell's going to ring shortly. Okay, so dv dt I have here. Yeah, but we're almost done. 4 pi over 3, just ignore it, but it's still there. What's the derivative of h cubed? Now, if you try to do the derivative before you simplify, you're in trouble. Guess what? You've got all the pieces here. Yes. So you can put them on my corner of my desk as you leave. What packet?